If you have done calculus before, give me a yes. Okay, Daniel has done it before. Who else? Left have done it before. Who else? Okay, boss. Okay, who else? Abraham has done it before. Okay. I have 8 participants. Abraham, Daniel, Jephthah, Kelvin, Sparky, and Emmanuel Mensah. Emmanuel, have you done calculus before? If you have done it before, give me a yes in the chat box. Give me a yes in the chat box if you have done it before. Okay, so since you have all done it before, I would like to drop a question before I will start. Okay, I want to know. I'm dropping a question and I would like you to privately send me the answer. I'll be dropping it very soon. Give me some time. Okay, so that's the question. I hope you can see the question.
Yes, we can.
Okay.
So is it S squared or?
Yeah, X squared. I forgot.
Oh, all right.
Okay, so you have like 2 minutes more. Those who are using the calculator, I've seen you. Okay, someone is entering with Galaxy Grand. Those using the calculator, I've seen you. They are punching it into the calculator straight for me. Okay, so per the answers, I think we have to start everything again, okay? So let's start calculus all over again. Okay, so calculus. What do you understand by the term calculus? Expressing a change in a function. The change of y to the change of x. That's all about calculus. So for example, in economics, you have a formula that is change of y over change of x. Y1, in mathematics, you have a formula like y1 minus y2 over x1 minus x2. They are all finding change, and that's mostly about calculus. And the formula that I talked about, which is y1 minus y2 over x1 minus x2, that's a formula that's associated with differentiation. But for integration is the opposite of differentiation. Okay. So for example, let's move on. So calculus is the study. Uh, 1 second. Galaxy Grand Prime, please, who are you? What's your name?
Jerry.
Derek.
Jerry.
Jerry. Okay. Since we have people who haven't done it before, let's start all over again. Okay.
Okay.
I'll be muting you. Daniel, I'll be muting you. Okay, so let's continue. So as I was saying, calculus is all about finding the differences between particular items or particular variables. When we talk about variables, variables can be A and B, variables can be C and D, variables can be weight in kilometers, variable can be whatever variable that is around. That's why normally we represent them with X and Y. Okay, so that's about calculus. And differentiation and integration. As differentiation is finding the change in one variable as it affects the change in another variable. Integration is like the opposite of differentiation. So for example, if you do a square root, or you have a squared figure, then you take the square root. That will take you to the former what answer that you had. So it's the same thing here. When you differentiate a function and you integrate that function again, you get the function that you had initially. So that's it. We have what we call limit. Limit in differentiation and integration, it's all bounds on limits. What are the limits that you have? What limits that function? Is that okay? So if there is a limit of 1, that means that whatever you are differentiating, you differentiate it according to that 1. So that's the limit that we are talking about. You differentiate according to the limit of 1. If there is a limit of 2, you differentiate according to that limit of 2. So the limit of a function is the foundation stone for differential calculus. So when you are differentiating, the limit is the foundation stone there. So we are going to learn about limits before we move on to differentiation, and we'll end with the rules of differentiation. Then next week, we continue solving more questions on differentiation to abreast ourselves with that. Then we move on to integration the following week. Okay. So limit of a function. If we have a limit of a function x, f of x, if we have a limit of a function f of x where x is approaching a, that's how we say it. So you have the limit of a function f of x where x is approaching a. You compute the value of that limit by this formula here. By this formula here. Since we are not using a raw board and we are using this, you see that the formulas will be a little shifting and the rest, but that's how it is. The lim of x approaching a of the function f of x will give us what? L, and the L is a set of real numbers. So whenever you find the limit of a function x, you have to get a set of real number. If you don't get a real number, then it means that there's something wrong with your question or with your answer. So for example, you have the limit of the function x where x is approaching 1. Therefore, you substitute this 1 into x because the equation says the limits of the function x where x is approaching 1. So you represent the x here with 1. Therefore, limit of x where x is approaching 1 is equal to 1. As simple as that. That's for limit. So you have the limit of x where x is approaching 1 will be equal to what? 1. Because you represent the x with 1. This x with 1. Okay. So that's about limit. Let's move on to the rules. The rules of limits. The rules for limits. Okay, so the first rule is a constant rule. The first rule for limit is a constant rule. And the constant rule is such that where you have a limit of a constant, where x is approaching infinity, when we say infinity, we mean x is approaching from 1 to any number that we can get, infinity. So the limit of the function k, which is a constant, where x is approaching infinity, will be equal to the constant itself, that's k. So for example, you have the limit of 9, where x is approaching 1. The answer is the constant itself. If you have the limit of 20, where x is approaching 20, the answer is 20. Because there is no x there. It's the same as when you have 9x plus 1 is equal to 0. Is that okay? Now, and you have the question tells you that where x is equal to 1. It's the same thing here. You have the limit of 9. X is approaching 1, where x is equal to 1. You replace x here with the 1 here. So you'll be getting 9 times 1. Is that okay? Now let's focus on this one alone. This one is a constant without any x. That means that you will not find any x attached to this one, where you have to replace this x is equal to 1 with this one. So it's the same thing here. You have the limit of a constant. Now that limit of a constant where x is approaching 1, you don't have any x around this constant to replace the 1 with that x. So the limit of a constant is the constant itself. I hope you get it. Give me a yes if you are understanding, or if you understand. Give me a yes if you understand. Okay, Daniel understands. Jefta, hello. Give me a yes if you understand. I do this to make sure that you are concentrating in class. If you understand, give me a yes. Okay, Jerry says yes. Yes, I'm waiting for the rest. Yeah. Daniel, as you have said, it's like substitution, okay? You substitute that 1 to the x, and if you don't have any x there, you can't do what? You can't substitute. Daniel has gotten it. Kelvin, Kelvin and Sparky. Kelvin says yes. What about Sparky? Okay, let's continue. Okay, so that's the first rule of limit, and you have to have it in mind so that whenever you are finding the limit of a constant, you will not worry yourself but write the constant there as it is. That's the first rule for limit. Now the second rule is the power rule. The second rule is the power rule, where the limit of a function x raised to the power n, where the limit of a function x raised to the power n, where x is approaching a. So if you have x raised to the power n where x is approaching a, as Daniel said, it's like substitution. So you substitute this a into where x is. Therefore, you'll be getting what? A raised to the power n and not x raised to the power n, as we have substituted a for what? X. For example, you have lim of x raised to the power 2, where x is approaching 3. Therefore, you substitute this 3 into wherever x is, and you're getting 3 raised to the power 2. That will give us what? 9. That's the power rule. So whenever you have the power, you make sure that the x approaching a, which is x approaching 3, you replace that 3 with the x, and that will give us what? 3 squared, and that will give us 9. That is what we term by the power rule. So that's the power rule in differentiation or in limits. Let's continue. The next one is the product rule. And this product rule is for a single function. So if you have a single function, this is the product rule. Now, this product rule says that limits of a function k of fx, where k is a constant. So k of fx, where k is a constant, x approaching a. Now what you need to do is to move the k from in front of the fx, move it behind the limit so that it will be multiplying the whole function where x will approach a. So let's take the example, then we can get it better. Okay, 1 second. Okay, so for example, For example, you have the limits of 2x cubed, where the 2 is the k here. So as I said, k is the constant. So 2 is the k here. And the x cubed is the function. Is that okay? So limit of 2x cubed, where x is approaching 3. Where x is approaching 3. Therefore, you move the 2 in front of the x cubed to behind the limits, so that it will be multiplying. This one will be multiplying the whole limit function here. Is that okay? So you can replace x with what? 3. Therefore, you'll be having 3 cubed, which is the first limit function, multiplied by what? 2. That is the function 2x cubed, limit 2x cubed. So that's what we term by the product rule, or that's what we mean by the product rule. This is the product rule in limits. You move the k back, then you do your multiplication, you do your substitution, then the multiplication, you'll be getting what? 54. Okay. After everything, I'll give you questions to solve right now. So get ready. The next one is the sum and differences rule. The sum and differences rule. The sum and differences rule. Now, this one, it's adding or subtracting two functions. Adding or subtracting two functions. So you either add two functions or you subtract two functions. So we have the limit of f of x, which is the first function, plus or minus, as the topic says, sum and differences. So plus or minus the second function, which is g of x. Is that okay? And in this example, I use the plus only. I didn't bring the minus. In this example, I use the minus only. So that's what you mean by plus or minus. You are either adding or you are subtracting. Okay? So with this function, what you need to do is to separate these two functions. So you have the first function, which is the limit of the f of x, where x is approaching a. So you have f of x, where x is approaching a. Then the second function, which is the limit of g of x, where x is approaching a. So you separate it into two functions before you solve the whole thing. So for example, we have limit of 3x cubed minus 2x squared, where x is approaching 2. As I said, this is the full function. The sum and differences rule says that you should separate these two functions before you do what? You add or subtract them. So you will be having the limit of 3x cubed, which is the first function, minus the limit of 2x cubed, which is the second function. With all the two functions, x is approaching 2. That means that the next function, you'll be substituting the 2 there. But can you see that we have another rule here? We have our product rule here, where there is 3x cubed. So we have to move the 3, and there's 2x cubed. So we have to remove the 2 and put it behind the limb. Is that okay? So this will be the next equation, which is 3 lim x cubed minus 2 lim x cubed, where x is approaching 2 in all two circumstances. Therefore, as I now, we can substitute our 2 into our the x here. So 2 will approach x, x will approach 2. Therefore, we have the 2 cubed, which is this function. Then we have 2 squared, which is this function. So when you solve it, you'll be getting what? 16. That is the sum and differences rule. It has to be in your head always. Okay. Now the next one, if you don't understand, put the question in the chat box. I'll attend to you, okay? If you don't understand, put the question in the chat box. I'll attend to you. The next one is the product rule of two functions. The next one is the product rule of two functions. Give me a second, okay? So in this rule, you have two functions, which is g of x and h of x, as we saw in the sum and difference, where we had f of x and g of x. This one, we have g of x and h of x. Okay, so we are taking the limit where x is approaching a. That's the product rule. It is multiplying. Okay, as you can see, it is multiplying here. So we have to find the product rule, how we can use the product rule. And with this one too, you have to what? Separate these two functions into two separate entities, and which is this and this. So we have lim of g of x where x is approaching a, and lim of h of x where x is approaching a. Exactly. So for example, we have the lim of x plus 3, then multiplied by x minus 2, where x is approaching 4. Therefore, we separate these two functions into lim of x plus 3, where x is approaching 4, then lim of x minus 2, where x is approaching 4. Okay. This one, we don't have anything in front, so we move on to substitute our x, which is equal to 4. Therefore, we have 4 plus 3 here, and we have 4 minus 2 here. 4 plus 3, which is 7. 4 minus 2, which is 2. You multiply them and you get what? 14. That is the product rule of two functions. Now the next one is the quotient rule. The next one is the quotient rule. Now quotient rule is about division. Product rule is about multiplication, and quotient rule is about division. Okay. Product rule is about multiplication. Quotient rule is about division. Now with this quotient rule, we'll be solving the question that I just gave to you. Be solving the question that I just gave to you. Okay. So this one too, we have functions g of x and function h of x, where h of x should not be equal to 0. So as you can see, h of x is the denominator. Whenever you have the denominator which is equal to 0, that function will be undefined. The calculator will give you undefined or something. Is that okay? It will be an undefined function. Therefore, h of x should not be equal to 0. Where x is approaching a, you'll be having the lim of g of x over the lim of h of x. So in all the instances, you could see that we are separating the limbs. Is that okay? So let's take an example which I gave to you to solve. Some of you had it correct. Some of you also had it wrong. Okay. So with this question, you have the lim of x squared minus 16 all over x minus 4, where x is approaching 4. X squared minus 16 all over x minus 4, where x is approaching 4. Therefore, it will be equal to the lim of, for this question, and if you don't factorize this one, you are going to get 0. If you don't factorize this one, you are going to get 0. And if you point the calculator, you are going to get 2 digits. You are going to get 0 and 8. That's how I saw that you were punching the calculator for me. Yeah, okay. So when you don't point the calculator, and you factorize, you are going to get only one answer, which is what? 8. Which is 8. So you have to factorize this one first, because x minus 4 and x squared minus 16 is the same thing when they are dividing. Exactly, because x squared, if you take the square root here, you take the square root here, you'll be getting the same x minus 4. So it's the same thing. Therefore, x minus 4 over x minus 4 will give you what? 0. That's how you get the 0. So if you point the calculator will give you 0 and 8. Either 0 or 8. So if you factorize, you'll be getting 8. If you don't factorize, you'll be getting 0. Okay. Now, you factorize it, therefore you'll be getting x minus 4 and x plus 4. If you have not forgotten your factorization, this is what you'll be getting. From the x squared minus 16, you're getting x minus 4 and x plus 4, all divided by x minus 4. Therefore, this x minus 4 will cancel this x minus 4. Then you'll be left with limits of x plus 4, that's this one, where x is approaching 4, that's this. Is that okay? Then you can substitute your 4 in. You get your 4 plus 4, which will give us what? 8. That is the quotient rule. That is the quotient rule. So don't forget that if we have something like this, you have to factorize first before you do what? You take the division, or you continue solving. Is that okay? Cool. If you don't understand, please put it in the chat box for me. I'll get to you. Okay. Since there is nothing in the chat box, I think we can continue. Then we have the exponential rule. We have the exponential rule. And the exponential rule is said that where you have the limit of f of x raised to the power negative n, f of x raised to the power negative n. Hey, sorry. 1 second. Yeah. Where you have the function f of x raised to the power n, where x is approaching a. Exactly. You put the limit and the function in one bracket, then you raise it to that power. Exactly. So for example, I forgot to write the example in it, so let's do it here. So for example, you have lim 3x, what should I use? 3x raised to the power 2. Is that okay? This is what you have. Lim 3x raised to the power 2. I'm using this symbol for raised to the power since I can't get it in this form. Is that okay? So we have lim 3x raised to the power 2. If you have such a question, you do what? You put everything, that's the lim 3x in one bracket, then you bring the power out so that the power will affect everything in the bracket. Is that okay? If you don't bring the power out and you use the power on only the x, you are going to have troubles here. Is that okay? So you bring everything out, raise the power 2. I hope you get it. That's the exponential rule in limits. That's the exponential rule in limits. Okay, so I have some questions for you on rules in limits. Then after that, we'll do the derivatives. Then we are out of here for today. Okay. Okay, so the exponential rule, Jefta wants me to go over the exponential rule again. The exponential rule is that if you have a limit of a function x, and this function x is raised to the power a certain number, which is n. Is that okay? Where x is approaching a, you put everything, which is the limit of the function x, in the bracket, so that this power, the n, will affect everything in the function. So as you can see, this power here, in this instance, affects only the function f of x, but it doesn't affect the limit. But there may be other instances that there will be something attached to the limb in which this power must affect. Therefore, the exponential rule is such that when you have this question, when you have a question in this form, you put everything that's the length of fx into the bracket before you do what? You raise the power there. So that this power will affect everything in this bracket. So that's the exponential rule. I hope you are clear.
Yes, yes, please.
Okay, thank you. Okay, so I'm putting some questions down for you. I hope you can see the screen. I hope you can see the screen.
Yes, we can see.
Okay, that's nice.
Yes, please.
That's the first one. Uh, you have to solve it in sequential order and send the message to me privately. has sent its answers. Sparky, it's left with A. The rest, I'm still waiting for you. But what's your real name, Sparky?
Sir, please, Grace.
You are Grace, eh? Okay, let
Yes,
me see your name.
okay.
Okay, so only Grace has sent. Oh, okay. The rest, I'm waiting for your answers. Oh. Sent is okay, Jeffter, you have sent it. I've seen it. The participants. Jeffter, Grace, Kelvin, Jerry. Jerry, Jerry, are you there? Jerry, are you there? Hello, Jerry. It seems Jerry is not around. Okay, let's continue. Let's continue. Okay, so for the first one, it is a limit of a constant. And from the first rule, we know that the limit of a constant is the constant itself. Exactly. The limit of a constant is the constant itself. So limit of 24. 1 second. So limit of 24 is 24. Exactly, because there is no x around. For you to insert the 2 there, for you to substitute the 2, there is no x. So the limit of a constant, which is 24, without any x, where x is approaching 2, is the constant itself. So the first answer is 24. A is 24. Is that okay? Good. Now the second one, limit of a function plus another function. Is that okay? Limit of a function plus another function. You have limit of 2. I will not break the x approaching 2 because of how this write-up is like. So you have limit of 2x squared plus 3x cubed. Is that okay? With x approaching 2. So what you need to do in the first instance is what? Hello? Can anybody tell me what you need to do in the first instance? Okay, so you have to separate them first, okay? So you have the limit of 2x squared plus the limit of 3x cubed. Is that okay? You have separated them. All is x approaching 2. All is x approaching 2. Then now the next thing is to remove the constants, which is the 2. From there and put it behind the limb. So you have 2 limb x squared plus 3 limb x cubed. With x approaching 2, you are going to get 2 into bracket x, which is 2. Raise to the power what? 2. Plus we have 3 x approaching 2, which is 2 raised to the power 3. Therefore, we are going to get 2 raised to the power 2, which is 4. 4 times 2 will give you what? 8. Plus 2 raised to the power 3 is 8. 8 plus 3 is 11.
So you should rather multiply.
Are you sure?
So 8 times 3.
Oh, sorry. 8 times 3, rather. 8 times 3, thank you.
You're welcome.
So you'll be getting 2 raised to the power 3, which is 8. 8 times 3 will give you what? 24. Is that okay? So 24 plus 8 will give us what? 32. I hope that's clear. So that's for the B. Now the C. We have the limit of a function which has an exponent. Okay. So all we need to do is to replace the x with the 2, which will be raised to the power the exponent. So it will be 2 raised to the power 5. And what's 2 raised to the power 5? 32. Is that okay? Now the next one, which is the limit. This is we are going to use the quotient rule here. Is that okay? So what you need to do, limit of 2x cubed plus 3 divided by limit of 2, all x approaching what? 3. Is that okay? I hope that's clear. So for this one, the first one, we have what? Sum and differences rule there, which is for the first one. So you separate that one. Let's put the limit of the constant there because we know that is the constant is of that's 2. Let's concentrate on the first one, which will be 2x raised to the power 3. 2x raised to the power 3 plus limit of what? 3. Is that okay? With x approaching what? 3. All over limit of 2. Now the next thing we need to do is to do what? To move this 2 to the back of the limb. So 2 limb x raised to the power 3 plus limb 3 all over limb 2. Therefore, you'll be getting what? 2 into brackets. X is approaching 3. Therefore, 3 raised to the power 3 plus lem 3, that is what? A constant. So it is 3 all over lem 2, which is a constant, which is 2. So 3 raised to the power 3 is what? 3 cube. Oh, I've forgotten that you are muted. Sorry. So that's 27. So we're getting 2 into brackets, 27 plus 3 all over 2. So we'll be having 2 times 27, and that will give us 54. 54 plus 3 all over 2. 54 plus 3, which will give us 57 all over 2. Punching your calculator, 57 divided by 2. You are going to get 28.5. How that's clear? So, okay. Oh, nice answers. Nice answers. Daniel, well done. Nice one. Jefta, nice one. Grace, nice one. Okay, that's it. Good. Hey, Jerry Daniel. Okay, so Jerry left. He's now coming back. Okay, so the last one, which is what? This is a product rule of two functions. So you have the limit of 4x cubed times x minus 2 with x approaching what? 2. This is a product rule with two functions. So you have to separate those two functions first. Okay, before we continue. So you'll be having the lim 4x cubed times lim x minus 2. Okay. You have to move the 4 from where it is to the back of the lim. So you'll be getting 4 lim x raised to the power 3 times lim x minus 2. Where x is approaching 2, therefore you'll be having 4 into bracket 2 raised to the power 3 times 2 minus 2. Okay. You can, that's why if you continue to solve cry now because you know that 2 minus 2 is what? 0. So 0 multiplying any number will give us what? 0. I hope that's right. Okay, so well done, Daniel. Well done, Kelvin. Well done, Grace. Well done, Jefta. Okay. Abraham. Is Abraham still here? I didn't. Okay, Abraham has left. I didn't see his answer. Abraham has left. Okay, so well done, all of you. Now, let's finish this fast and we can leave for today. No, I think we will leave that for next week. Okay. So, correspondence, why? Was this end? Okay. Let's finish with the derivatives. Okay, so now what we did was just the preliminary for differentiation. Okay, we have to know how limits work in differentiation so that we can use it. Now we are going to talk about differentiation itself, which we will start with the derivatives. Okay, now it's all about a change in one variable affecting the change in another variable. A change in one variable affecting the change in another variable. So you have a change of x over change of y, where you'll be having y2 minus y1 over x2 minus x1. That's differentiation. That's all it is to it. Is that okay? So we're having a change in one variable over the change in another variable. But in this instance, you'll be having x approaching some particular number. Is that okay? It's the same thing that you have done, but just that this is a little bit technical, a little bit technical. So derivatives is the mathematical way to find a change of one variable to a change in another variable. That okay. A mathematical way to find a change of one variable to a change in another variable. Now, given the function y is equal to fx, given the function y is equal to fx, the derivatives of the function f at x will be written as f prime of x, f prime of x, or y prime, or it can be written as what? Dy dx, and they are known as total derivatives. We have something we call partial derivative. That's where you'll be hearing dy y dy x and the rest, but I think for this level it's not needed. So you'll be knowing all about the total derivatives. Okay, differentiating totally and not partially. Totally and not partially. So we'll be talking about the total derivatives here. Now, with total derivatives, where y is equal to f of x, you can either have f prime of x or y prime or dy dx. In any instance, they are all the same. They are known as the first derivative. So the first derivative, where lim of f of x will be f into bracket x plus the change of x. That okay. We have x plus the change of x minus f of x all over the change of x, where change of x is approaching 0. So where change of x is approaching 0, this place will be 0, this place will be 0. Is that okay? And to give us an undefined function or the same function. So that's a formula that you have to know. Rules of differentiation. Now, rules of differentiation, differentiation is very simple. Okay, it's very, very simple. Now, when you are differentiating a constant, is 0. When you differentiate a constant, is 0. So when they tell you to differentiate 2, it is 0. Is that okay? When they tell you to differentiate 2, it is 0. When they tell you to differentiate 3, it is 0. Is that okay? So that's a rule in differentiation. If you are told to differentiate a constant, is 0. Now, the linear function, if you are told to differentiate a linear function, where f of x is equal to mx plus b, therefore, the f prime of x, what you do in this instance, when you have mx plus b, and you are told to differentiate, what you will do is, you pick the exponent of the x. In this instance, the exponent of the x is an invisible one, which we all know. Is that okay? You pick that one and you multiply it by the mx. Is that okay? After that, you subtract that power from 1. Is that okay? So if you had something like 2x squared plus 3x, if you had something like 2x squared plus 3x, and you are supposed to differentiate this function, is that okay? What you do is you multiply the exponent by any number in front of that x. Is that okay? So in this instance, you get 2 by 2. Is that okay? 2 by 2. Then x raised to the power, then you subtract 1 from the exponent. That's 2 minus 1. Is that okay? So you multiply the exponent by any number in front there. This one is 2, 2, 2, so it seems it is a little bit confusing. Let's use the second one there, which is 3x. Now 3x has an invincible exponent of what? 1. So you multiply that 1 by the 3 in front of the x. Is that okay? Before you subtract 1 from the exponent, which will give us what? 1 minus 1. Is Exactly. So in this instance, when you are told to differentiate 2x squared plus 3x, you get 4x, which is the x squared. You are subtracting 1 from the 2, and that will give you what? X raised to the power 1. If it will give x raised to the power 1, you know that anything raised to the power 1 is the number itself. So x raised to the power 1 is x. Then plus, you multiply the 1 by the 3, that will give us 3. Then x raised to the power 1 minus 1. 1 minus 1 will give us 0. Indices tells us that any number raised to the power 0 is equal to 1. So multiplied by 1. Therefore, you get 4x plus 3. That's what you get when you are told to differentiate a linear function. So you multiply, first you multiply the exponent by the constant in front of that variable. Then you subtract 1 from that exponent. If we are told to differentiate this 4x plus 3, now let's differentiate 4x plus 3. The answer that we have gotten, let's differentiate that answer again. If we are going to differentiate this answer, we are going to multiply the invincible 1 by the raised to the power x raised to the power 1. So it will be 4 times that 1, x raised to the power 1 minus 1, because you subtract 1 from the exponent, plus any constant that you differentiate to give you 0, because there's nothing there for you to do what? To differentiate. There's no x there for you to differentiate. So you'll be getting 0. And that will give us what? 4. Because 1 minus 1 will give us 0. X raised to the power 0 is 1. So that will give us 4. So that's the linear function rule of differentiation. And this is what you'll be doing in differentiation every day. So when I give you something like 2x cubed, differentiate 2x cubed, you know that you have a power 3. So you multiply the power 3 by the 2 in front of the x, and that will give you 6. So that will be 6x. Now, the power 3, you subtract 1 from the power 3, and that will give us what? Power 2. So that will give us 6x squared. Therefore, what I was talking about, differentiate 2x power 3. You multiply 3 by the 2. Then x raised to the power 3 minus 1. And that will give you 6x raised to the power 2. 6x squared. That's what you will be doing basically in differentiation. Then the power rule is the same thing as what I've said. Exactly. When you have a constant, you have kn kx squared. If you have kx squared, you multiply the power, that's the n. In this instance, the n. You multiply it by the constant, that's the k. So that will give you nk. Then x n minus 1. You subtract 1 from the power. That's how you differentiate. Exactly. These are the rules in differentiation. I'll give you some limit questions to try your hands on them. Next week when we come, we will delve deeper into differentiation. We will try and do some applications of differentiation. And the following week we will do the integration. Okay. Thank you for your time and your audience.